Okay, so now we're going to talk about making alkyl halides from alcohols. We're going to talk a whole lot more about this particular way of making alkyl halides in the context of Chapter 11, where we'll deal more with the mechanism and why we have to pay attention to what degree the carbon is that has the OH on it before you know exactly how you're going to proceed. For now, what you need to know is that if you have a tertiary alcohol and some of the secondary alcohols, all you need to do is use HX, and X is our shorthand notation for halogens. So HCl, HBr, HI. You can just use an aqueous solution of the acid, shake it up with the tertiary alcohol, and you can make the alkyl halide. And they have this chart on here to tell you this works best with tertiaries. Some of your secondaries are going to work, but the primaries and the methyl alcohol just don't work. And like I said, we'll figure out why that is a little later. So here's an example. And they even have HF in here. We haven't talked a lot about fluorine, but even HF you can do. And so you can take this as a secondary alcohol, and this is a pretty reactive molecule, so you can get that, it says, in very good yields. Here's an example of a tertiary alcohol, aqueous HBr, and there you go. Your side product here is water. And so you have a pretty easy time of making these things. It doesn't take very long. It's really easy to do. Now, if you have other degrees of alcohol, so methanol, just the methyl group attached to an OH, if you have any primary alcohols, and even a lot of the secondary alcohols, we're not necessarily going to be able to use HX. And the reasons, like I said, will become more clear in Chapter 11. So we have some new compounds to learn about. So for chlorine, we have this molecule right here. This is called thionyl chloride. And it's pretty cheap, it's pretty common, you can buy it, and it will react with an alcohol to replace the OH. So this is a substitution reaction. Substitute a chlorine for the OH. Now, you don't actually give away an OH, you actually incorporate the oxygen and the hydrogen into two different gaseous byproducts. So the oxygen becomes incorporated into the SO2 molecule, and the hydrogen goes with the other chloride ion out of here, and so you make HCl, and I've noted that both of those are gases. The importance of that is that the side products just kind of go away, so it's easy to clean this material up. The downside, of course, is that HCl and SO2 gases are pretty obnoxious, so if you were trying to do this on a large scale, you have to have some way of dealing with those side product gases that you don't want to just pump those out into the air. But that can be done. For bromine and also for chlorine, we have another kind of reaction. This is PBr3, phosphorus tribromide, or there's a similar compound, phosphorus trichloride. And you can use that, and you balance the equation where 3 molecules of alcohol react with 1 PBr3, and you can make 3 molecules of the alkyl halide, and this side product, which you could also write like this, which looks like phosphorus acid. And so you have to deal with getting rid of that. It's a little bit more work than getting rid of the gases from SO2 and HCl gases, which just kind of went away on their own. You have to actually separate this, but you also have the 3-to-1 ratio, which is kind of efficient. So it takes less reagent to accomplish this transformation. There's just more purification. And like I said, you could use the PCl3, and so if you had problems dealing with these gases for the chlorine, then you could use PCl3 instead, and then you just have to deal with purification again. So these are both common reagents. The downside for this is that there's no similar thing for iodine, so we'll learn about that in the next chapter if you want iodine on a primary or a secondary alcohol. So here are some more examples. So here's a secondary alcohol, and they've used the thionyl chloride, and you'll notice they have pyridine here, and the purpose of the pyridine in this example is to make a salt with the HCl byproduct, which they haven't shown that, but that's why it's there. And so it's substituted a chlorine for the OH, and of course you have these byproducts which are going to get tied up with the pyridine. And here's another secondary alcohol using the PBr3, and this reaction is run just barely over room temperature, also pretty easy to do, and there's your byproduct which you would have to get rid of. So that is all that they presented about using these alcohols as ways to make alkyl halides. But I wanted to also remind you that what we've done in this chapter is we've refreshed our memory on how to make alkyl halides from alkenes, and that when we did that, we could do halogenation or hydrohalogenation, and those reactions were from alkenes from chapter 8 used up the double bond. And so we exchanged the alkene functional group for a halogen or two halogen functional groups. And then in this chapter we talked about allylic bromination, which allowed us to keep the double bond so we don't use it up. The downside, of course, is it was only useful if we had a simple cycloalkene or propene, or else we got mixtures. But we took advantage of that reaction to learn something about the resonance stabilized allylic position radicals and what all that meant. We also talked in this chapter about making alkyl halides from alkanes, and that was the free radical halogenation of alkanes, which also produces a lot of products, mixtures and so forth, depending on all the different types of hydrogens you had on your alkanes. And of course we looked at that because we were interested in the free radical mechanism of that reaction, and reinforces our knowledge about radical reactions. And then in this section we've just talked about making alkyl halides from alcohols, and so here what we really need to do is pay attention to the degree of the alcohol, and so we can either use thionyl chloride or PBr3 for methanol or primary and most secondary alcohols. If it's tertiary or if it's a crowded secondary, then we're going to use HX, and we can even get fluorine in there, but we can actually do all four: chlorine, bromine, iodine, and fluorine with HX, but we don't have any way to get the other halogens, fluorine or iodine, in with this kind of process. We'll have to wait and see how to do that in chapter 11. So that's the end of this section of material.